Welcome back to the Algebra 2 series, where today we're looking at a quadratic model, in particular a rectangle with 3 sections, and we're trying to maximize the area given a fixed perimeter. In this case, we have 160 feet of fencing, and we're trying to maximize the area given that the barn is being used as one of the sides. So as we label X for the length of one of those partitions, we notice we end up with 4 of those X's, 2 for the outsides and 2 for the partition breaks there. And then we have the length of this base, which will be, if the whole length is 160 feet, 160 minus the 4 X's that were used for those sides. Writing an area function for this is not going to be that hard because it's a rectangle. So a of x is equal to the base times the height, or in this case I'm going to write it as height times the base, 160 minus 4x. Written in quadratic form in descending order, negative 4x squared plus 160x. And that represents a function that will give us the specific area given any length of x. And of course, the domain of x would have to be between 0 and 40, 40 being the maximum number that x could be using all of the fencing for those lengths. Well, if you work it out using negative b over 2a, you end up with an intriguing answer. For example, here you end up with negative 160 using the b from the function, and then 2 times the a value, which is negative 4. The negatives cancel here, and we're left with just 20 for the x value. So x is 20. That gives us the x value for the maximum. This would be right here. And that would mean each of these is 20. So 20, 20, 20, and 20, which leaves the remaining amount, 80, for the long side. So this would be 80. We've done several of these in class, and we've come to notice that a pattern starts to evolve. And thanks to Kaishu, who's in one of my classes, we determined, and he found that if you just take the 160 feet and you divide it in half, or divide it by 2, and you give half of the length to the long part, or the single side, and you give the remaining half to the other partitioned sides, you will always get the maximum area. And so, of course, we wanted to make certain that this works. So I wanted to start out with a couple of concepts here. This is a very intriguing idea. So let's start with the box itself. And in this case, we do not have a barn, so we have 2 sides rather than 1. And in this case, we're not even certain how many partitions there are. There could be a total of 5. You see 1 here, 2, 3, 4, and 5, if you're counting the outsides as partitions. But this creates 4 pens. There could be more of them, or there could be less, so we don't really know. In this case, I'm going to make it arbitrary by just saying I have some partitions. And so this will be x, and then I'll also put here n partitions. Uh, and we're assuming, of course, that the sides, the outsides, are considered partitions as well. And this length down here is going to depend on x, on n, and also on the total perimeter. So the total amount of, let's call it fence in this case, is going to be, I'll just call it P. I realize it's perimeter and it's used for all the parts. But anyway, we'll just call it perimeter. If that's the case, then the length of the base would be the perimeter minus all of the partition values. And in this case, we're going to say there are n of them, and that would include the outsides. So that would be n times x, and we would divide this by 2, and that's because we have to split it between the 2 sides there, the top and the bottom one. So that's why we have to divide this one by 2. And I wouldn't do this in the case of the barn example. I would just leave it as p minus n times x. All right, so we're going to use this one and rewrite that area formula. A of x is equal to base times height. Now again, the x is representing the height. The n doesn't have anything to do with the height. It's simply the x that's the height. So the area is x times p minus nx all over 2, or written in quadratic form, this is going to be, and I'll rewrite this another time, um, xp minus nx squared, and this is all over 2. So let me finish this out just to write this properly. This is negative n over 2x squared plus p over 2x. That's our a of x. Okay, notice we do end up having n's and p's in our function, but that's okay. We can still calculate negative b over 2a, which should give us the x value that will maximize our area. And of course, and before I finish this out, notice that this negative implies that our parabola is facing down, and therefore we will have a maximum rather than the opposite case occurring. All right, just to clarify that part of it as well. Let's figure this out then. The negative b, or the opposite of b, is negative, and this is going to be p over 2, and this is all over 2a to negative n over 2. Well, I think we can all see here that the negatives will cancel, and so will these little mini denominators. They'll cancel out, giving us p over 2n. And so this is the value of x. Of course, negative b over 2a is representing the x value that will maximize area. The perimeter divided by 2n. Well, let's go back up here then. If x is going to equal p over 2n, then the number of partitions will make a difference in how much we have. So let's separate this just a bit. Let's just take the perimeter divided by 2, and once again this coincides with what Kaishu had said, was take half of the perimeter and give it to the up and down partitions, and then multiply it by 1 over n. In other words, you're going to have to take into consideration how many total lengths there are. So this does coincide with it, and it does help us out now to understand how we're going to divide things up. Half of our perimeter is going to go to these legs, and half will go to these legs. Now let me finish this out by then creating an example that's now easy to compute. So let's try that. We'll make a rectangle, and we'll say, let's have a given number of partitions. So here we go, and this will be our x, and then this will be our other side. And for example, here we want to maximize the area. Given, and then you can make up any number you want. 180, I'll just make that up. 180 feet of fencing. Well, first step is to take 180 and divide it by 2, and that gets us 90. And that means 90 and 90 are going to be split between the vertical, and I say vertical on our picture here, and the horizontal. Of course, x is here, 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 and here, and that makes 5 x's, and that's going to be given 90 feet total. So x here is going to be 18 feet each. And of course, the other 90 is going to go to the bottom, so that's going to be 45 on the bottom and 45 on the top. So very quickly we can see that our partition length, this x value, will have to be 18, and the total length is going to be 45 in order to maximize our area. So that was quite intriguing that we were able to discover that. And then the last thing that we discovered was, if you notice how this works out, let's put the barn back into play and contrast the difference between the two. Notice that in this case, the only difference between a freestanding rectangle, like this one, and one that uses the barn is that this top piece is not used because of the barn. So this guy is used, and therefore the second perimeter is going to be divided by 2. Now let's take a look at this a little more closely. If you go back to our original example, or any example, and let's say we had 160 feet of fencing, we can calculate quickly when we divide that by 2, we'll get 80, and so each of these will have to be 20. and this would leave us with 80 here. But the answer is also the same on the other one. This is 20, but this is going to be 40 because we have to share it with the top section. So the take-home message here is that we can double the area if we use the barn. Now, if you tell a farmer that he can double his area by simply using his barn as one of the sides, I think he would be kind of surprised that all he has to do is take off this amount and use the barn instead, and he'll be able to double the area of his pens with the same amount of fencing. And that was quite a discovery. Hope you enjoyed that.